Hello and welcome to factoring a sum or difference of cubes. This is a type of factoring. So far we have done difference of squares. We've been doing factoring when a is equal to 1, meaning it's just an x squared, as well as a does not equal 1, which we did something called the AC method. Unlike those other ones, these are going to be when you have like x to the third power, sometimes x to the sixth power, but most of the time x to the third power, which is why it's called a cube instead of a square or a quadratic. And there'll be a number in front, and that number is also going to be a perfect cube. So like I said, it's going to be a specific type of factoring. It doesn't come up very much in problems, but it is something that happens, so we're going to learn it. First of all, just to kind of compare what we've done in the past, we used to have something that's 3 terms long, like this, and when you got an answer, it was 2 sets of parentheses, and each of those sets of parentheses had 2 things in it. For this specific problem, if you were to do it yourself, you would see it's x plus 3 and x plus 4. It was 2 terms each, they are binomials, and it's 2 sets of parentheses being multiplied. Your answer for sum and difference of cubes is actually going to physically look different. Instead of 2 terms times 2 terms, what you're going to have is 2 terms, but this time it is going to be multiplied with 3 terms on the second parenthesis. So just know that if you come up to a problem that you know for a fact is a difference or sum of cubes, you might as well immediately go ahead and write down 2 sets of parentheses where one of them is going to have enough space for 2 things, and the next set of parentheses is going to have space for 3 things. What's going to happen after that is you're going to be having, a plus or a minus sign between these terms. And there's an old trick we use to find out what those signs are going to be, because it's actually pretty standard in every single problem. And the way we remember it is through this acronym called SOAP. And it's just a really clean method of remembering of what the signs are going to be, whether it's going to be a plus or a minus. So if you have a plus or a minus in the original problem, like you'll have something like x to the third plus or plus 8 or minus 8. This is what the original problem would look like, and you're supposed to factor it. What the S stands for is that in your answer that you're going to have over here, the first thing is going to be the same sign. So if it was a plus, then the same thing would be a plus over here. The O stands for opposite. So if this was a plus in the original problem, that means the next sign would be a minus, because that's the opposite. The opposite of a plus is a minus. And then the A and the P go together. It is always plus or always positive, whichever one you like to say. I usually say always plus, but always positive is the correct math way of saying it. Where it doesn't matter if it's a plus or a minus up here, this is always going to be a plus sign right there. So if it was a plus sign, the signs will be a plus, a minus, and a plus. Whereas if it was a minus sign, then this would be the same sign. This would be the opposite sign, so this is actually a plus now. And then it's always positive there. And that is how SOAP works. It is the signs that is going on. I have so far not told you anything about what numbers and letters are going to go here. But you can always, in every single problem, just immediately write this stuff down. For example, for the first one, before I even talk about how to factor it, I know it's a perfect cube. I know I'm going to have space for 2 things here and 3 things here. And I know that since this is a plus, we will do same, opposite, always plus. So since this is a plus, we'll have the same, we'll have the opposite, and then always a plus. And then we'll just have, 2 terms here and 3 terms here that we'll put. Whereas for when we do number 3, we could start out, once again, 2 things over here, 3 things over here. But this time, since it's a minus, same, opposite, always plus. Since this is a minus, the same thing is a minus. The opposite thing is a plus, and then it's always plus. So you can get that much information down before you even look at the rest of the question. All right, so we are going to go ahead back here, and I'm going to do the formal formula, which is this. If you have a sum or difference of cubes, it's going to look like this. You'll have a to the third plus or minus b to the third, where a could be a number, a could be a letter. It could be a 7, it could be an x, doesn't matter. Same thing here. What you're going to do in this one is it'll be a, b, a squared, ab, and then b squared, like so. That is the formula. It's the way it is written when you actually do this. So for an example problem, what you would need to do is when you start out with a perfect cube, you actually have to cube root them to get these numbers. So in our first example, this is an x to the third. So if you cube root x to the third, well, the cube root of x to the third is just x. So this is going to be an x. The cube root of 125. If you don't remember how to take the cube root of a number, that's the thing with the number tree. But you'll probably just start to recognize that, you know, if it ends in 5, this is going to be 5, and it does. The cube root of 125 is 5. So this would be a 5. After that, the way I remember what goes in these parts over here is you square what I consider the first thing. In this case, x is the first thing, so you would square x. In the second one, what you're going to do is you're going to multiply the two terms, like if this is the first and this is the second. If you multiply x and 5, you would get 5x. And then in this last blank over here, you're going to square the second. So 5 squared is 25. Because, you know, as we did up here, you square the first term, you multiply the two terms, and you square the second term. Right? If this is the first term, this is the second term. Boom, boom. So you square the first thing, you multiply the two, and then you square the second thing. A squared goes there, b squared goes there, and you multiply them in the middle. That's how it works. And after that, it's just a bunch of practice. We already did the signs for number 3. If you cube root x, you get x. If you cube root the 64, that's 4. If you need a reminder of how to find cube roots, I'm pretty sure that's in a different video that you can rewatch on simplifying roots. Okay, so you take the cube roots, you get x and 4. You square the first thing. You multiply the two things together, so the 4 and the x is 4x. And then you square the second thing, so 4 squared is 16. A lot of people ask me, why is that not a minus 4x? X times negative 4 is negative 4x. And my answer to that is just remember we already took care of the signs. Once we put the minus here, the plus here, and the plus there, you don't have to think about it ever again. It's just done. Don't worry about whether positive or negative makes negative. It'll always just work out. This always is a plus. It will never be a minus because it is always the opposite of that. So don't think too hard. Just take the two things, multiply, and put them there. Don't worry about negatives or positives. All right, here's some more examples. I'll do another example, and then I would suggest kind of pausing the video, see if you can do some. Perfect cube right here. I'll set up my set of parentheses. This is a plus sign. So same, opposite, always plus would be the same as a plus is a plus. The opposite of a plus is a minus. And then always plus. If I cube root a cubed, that's just an a. And if I cube root 64, that's 4, because 4 times 4 times 4 equals 64, right? Because it's 16 times 4. So 4. If I square a, I'll just get a squared. If I multiply a times 4, I'd get 4a. And if I square 4, I get 16. And that's the answer. A plus 4, a squared minus 4a plus 16. Done. If you think you got it, go ahead and pause, try these next 3. I'll quickly go over the answers. And then we'll do some things that also involve having a greatest common factor. Okay, so it's a perfect cube. I know because I'm able to cube root both of these. So I'm going to set up my parentheses. This will be a u and this will be a 2. 2 times 2 times 2 is equal to 8. Same, opposite, always plus. U squared, 2u, and 2 squared is 4. Feel free to rewind at any time to rewatch. This one would be an x and a 3. So you have x squared, 3x, and 9. Square, multiply, square. This is a minus, so this will be a minus. Same, opposite, always plus. This one's in an opposite order, but it doesn't matter. The cube root of 125 is 5. The cube root of x cubed is x. Square the 25. Multiply the 2 to get 5x. Square the x to get x squared. And then with SOAP, oops, same. That should be a minus. Same, opposite, always plus. There you go. Sorry about that. That is a minus sign. Okay, that's that. Let's do some where we have a GCF, or 2 numbers. It's going to be the same in the second step. You just have to see about greatest common factors. Like this one, you can't cube root these yet because you can't take the cube root of a to the 4th. But if you look closer, you'll see that they both have an a, so you can actually factor an a out of it. These also might have a number in common, but we can check. 2 does not go into them. 5 does not go into them. Maybe 3. We can do the 3 check. 6 plus 4 is 10. 10 plus 8 is 18. 3 goes into 18, so 3 goes into this one. 1 plus 0 plus 2 is 3. Plus 9 is 12, so 3 goes into 12. So 3 goes into this one. So 3 goes into both. So we can pull out a 3 as well. And if we do that, we would end up with, let's see, 216 plus 343, I believe. I think that's what you get when you divide it by 3. And then we'll take cube roots of both parts. It should be doable now. So the 3a will stay there. We'll set up our 2 parentheses, one big, one small. The cube root of 216 should be 6. And 343 is going to be, let's see, 343. I think 7 goes into it. 4 goes into 28, 63, 9. Yep, 49, so that's 7. Okay. Sorry. I'm doing my little tiny number tree. I'll assume that there's 3 of a kind with 7. So it is definitely 7, and because there's an A3, this is an A as well. Ooh, okay. This was a plus, so same, opposite, always plus. 6 squared is 36. 6 times 7a is 42a. And 7a times 7a is 49a squared. There you go. Bigger numbers and a GCF there. 16 is a little easier. You set up your parentheses. The cube root of 8a3 would be 2a. Cube root of 125 is 5. 2a squared. Remember that 2a squared is the same thing as 2a times 2a. I'm saying this to make sure that you are squaring the 2 and you are squaring the a. So 2a squared is going to be 4a squared. You have to square both of them. 2a times 2a. Then 2a times 5 is 10a. And 5 squared is 25. This was a plus, so we'll do SOAP. Same, opposite, always plus. Okay. 18's tricky. If you want to give it a shot, pause and try. Otherwise, here is both of them. Parentheses, cube root of this is 4x. Cube root of 1 is 1. If you square 4x, you would get 16x squared. If you multiply 4x and 1, you just get 4x. And then 1 squared is just 1. This is a plus, so this will be a plus. Same, opposite, always plus. So plus, minus, plus. Boop, 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 boop. All right, and then the tricky one. It's tricky because it does have a GCF of x. And if you don't notice that, you're kind of not going to be able to get anywhere. So you can pull out an x. And when you divide both sides by x, you would get 8x to the third. And then over here, you have the plus sign still, and you take away an x from an x, it ends up to be 1. So then cube root, 2x and 1, 4x squared, 2x and 1. This is a plus, so same, opposite, always plus. All right. So if that was, too fast, then feel free to rewind, watch it again, and pause and stuff. But that is the process of it all. So remember SOAP. Remember the formula from the front as well. Right there. That's how it's going to work. Don't worry about that. Okay, hopefully that helped. I'll see you next time.